In Tuesday's video, we talk about basic element of assembly language. We show you some instruction statement. So now we will see more detail how we will define data. So in order to talk about how to define the data and assign the value, so the first thing we need to know what kind of data type including in the assembly language. So then we will see how to add the variable definition in our add-to program. So sometimes you also can declare some data variable, actually they are uninitialized. So in assembly language, basically we need to only specify the size for the variable, how much memory size they will reside. So as we say before, we have byte, that's 1 byte, word 2 byte, D word means double byte, so that's 4 byte. So then we have quarter word, that's 8 byte. And also we have the terabyte, that will be the 10 byte. So all those bytes, word, D word, Q word, they are unsigned value. So sometimes, because remember we told you the value we want to calculate, you want to be signed or unsigned is user defined. So that's why the same thing, you define a variable data, you want to calculate as the signed or unsigned. If you want to calculate as the unsigned integer, you declare 1 byte, 2 byte, 4 byte, and 8 byte using byte, word, D word, and quarter word. However, if you already know your calculation is working on the signed integer, so then you just need to add s. So that will make those data type become the signed integer. So that will be the s byte, s word, sd word, and sq word. So that's usually what we use for the data type define. But also they have more, which one we may not use that much because we don't talk about the floating point number. So we have real 4, real 8, real 10. So that we are not including in this class, but that's also good to know. And also some data, they have the legacy data directive. But the same thing in this class, we focus on using byte, word, D word, and quarter word. So just to show you, sometimes we have those things for the before. There are several directives that still support it, but seldom used. And also for this class, we just recommend you to using this byte, word, D word, or quarter word. So then if you want to do the sign, you just add s from. So after you know the data memory size you want to work, so then here is how we would declare our data definition statement. A data definition statement set aside storage. So you need to specify the storage mean how many bytes in the memory for a variable. So optional, you can assign a name to the data. So this one actually will show you they are optional to assign the name label. So later we will show you, because sometimes you want to have only one name beginning of the data, then followed by many value, like array. So then in each line, you don't have to always give them the name label. So the name actually is optional for your data definition. So later we will show you when we do the array declaration. But here we just show you, typically you do this way. So this way the syntax is, you see you have the name. Even we give you the square bracket, mean they are optional. However, here, if you want to only specify define one variable with a specific size and give them the initial value, you see the variable name, or we just call that's the data label, followed by the memory size. So we have 1 byte. Then the initial value is 10. So then you will have one variable resize 1 byte, the value is 10. So what happened from here? So after you do this line, right? So after this line, we execute that. So you will see here, that's what happened in memory. So that's I show you here what happened in the memory. You have a value 1 NAND. This NAND refers to the beginning for this memory address. So value 1 actually is a memory address. Point to this location. So then you tell me you want to reserve for 1 byte, right? So the size from here is 1 byte. So then your initial value is 10. So of course, we are not really putting the 10 in this memory address. They will convert, become binary. But here I just want to show you to let you understand here we have 10. So that's happened in the memory. From now on, in assembly language, you need to be very clear. Every statement you declare, they actually happen in the memory. So that's how the memory look like. So you define value 1, then byte. They start from this location, reserve 1 byte, then put the 10 in here. So of course, that's one example. You can continue have more data definition. So that's why here, sometimes, this one actually, let me write down. Suppose this one, before you start doing that, you will do the dot. Before you start, you have the dot data. Those data declaration is under the data block. So then you can see here, I have value 1 is byte. So I have a value. So continue, say value 2, byte 0. So then value 3, byte 255. So value 4, sign byte. So you have value. So 1 by 1. So how they look like will be here. All those things happen 1 by 1 in the memory address. So on the other hand, you will see here. Of course, you see you continue. You have the value 4, right? So value 4, we say that's sign byte, but they are still 1 byte only. So then your value here will be negative 128. Okay, so continue, you know you have value 5. So then your value 5 just continue after your value 4. So then they have the label value 5. So we still are sign bytes. So then we do the value put positive 127. So the last one, you have your value 6. Okay, so your value 6, actually they still do the 1 byte. But see here, the question mark, that's me. They were using what's the value before. They don't initialize anything. So if you do the question mark, just me. They don't clear what they have before. So I just leave that because earlier I copied as 10. So maybe I just use like that. So that you can see here is your data declaration. But in assembly language, it's very important. You need to image your statements after you do the data declaration. Then in memory, what they really happen. So that's 1 by 1 from your statement. So for this example, you see each statement, they have the label name, size, initialization, the value. So you do 1, 2, 3, 4, 6 statements. They just have each statement, they do have their name label. So that's like in C++, you define 1 variable, so 1 value. But in assembly language, you also can try to define the array. So when you define the array, they look like this. Okay, so for example, here I have the name called list1. I have the data size is byte. But earlier when we define, we only give you 1 initial value. But if you continue using the comma, you have 10, 20, 30, 40. What happened is, you will see here, they will in the memory address like this. I have the list 1. Okay, so let me show you list 1 actually is here. Yeah, list 1. Okay, your list 1 is your name label, right? So they refer to the beginning for this address. Let me put on the right hand side. Okay, so they are beginning for this address. So then, of course, you have your 1 byte. So that's why here, let me show you each one, they are actually 1 byte. That's how they look at. So you only declare one list, one. They start from this location. So then each one is 1 byte. You only need to declare one time. So then later you have 10, 20. So they just have each byte 10, 20, 30, 40 to fill out the value. So that's why, did you see this one is what? Don't you feel this one look like the array we have? When we have the array, we only have the array name at the beginning. So then since we know all the array data size is the same, so we just following one by one. Okay, so you can do that by one name. Okay, so then one data type. So then multiple value. Or you can see list 2 is also one array as well. So list 2, you have byte. Then your size is byte. So then you have 10, 20, 30, 40. But then the next line, you don't have to give them another data label. They just continue after the 40. They have 50, 60, 70, 80. They are byte. So then you have 81, 82, 83, 84. They have 1 byte. So on the other hand, in the list 2, they will look like this. So list 2 will look like this. You see, you have list 2. You start from beginning for this location. Okay, so then you have continue, they are all byte. So then 20, 30, 40, 50, 60, 70, 80. Of course, you will continue. You have 84, 81, 84, 83, 84. But I don't have enough room for that. Or I just do this way. I need to make that smaller. Yeah, so that's how the list should look like. Okay, so that's in the memory location look like this. So within a single data definition, its initializer can be used different radix. So here we're only using, if we don't specify, that's mean decimal in the programming language, in the your source code. But also you see, you can also be character or string literal. So then you see from the following example, that's all the number here. But also we can see they also can be like this. They can be 10, 32, but 41 here is hex. Or combined with your binary number, but they only occupy 1 byte. So you see, you can combine with the hexadecimal, or you just give them the character value. So then you have the hexadecimal number. So they can have all the radius you need. So that's how to define the byte array. So this one we show you how to define a byte variable and byte array. But also you can define string as well. So when you define a string, it's implemented as an array character. So we all know string actually is just an array of the character. So each character is 1 byte. So for convenience, it is usually enclosed in quotation mark. Can be double quote, can be single quote for assembly language. But don't forget, they have to have the no terminated. So you need to have the 0 character, the no character at the end. So that's how we define the string. So string, label name, byte, because it's each character. So then you see, you can do the double quote. You can do the single quote. Okay, but don't forget, since you want to have a string, at the end we have the no terminator. And here, sometimes you can see you can have multiple line. You can have 1 line, continue byte. So then the whole thing will come to the encryption demo program created by the KP Irvine. So that's actually is 1 string from beginning to the end. Then we have no character. So sometimes your string, maybe you want to have a big information to display. So that's why if you want to have a new line, so that's our menu string, byte. So then you see you have the choice. So then we will show you the ASCII for the carriage return. So that's mean the return. So beginning to the beginning of the return. So then you have the 0DH, that's the carriage return. So then 0A actually mean the new line. So that's why you see the whole thing, they will have a new line for 6 line for a string.